Welcome everybody to a Unity 3D tutorial. My name is Dave and I'll be leading you through everything you need to know to create this game here. So you may be asking yourself, what is this game? This game is a procedurally generated infinite runner that we will create in 3 hours. Everything in the game is going to be created out of primitives, and everything in the game is going to be procedurally generated, so every time someone plays the game, it'll be different. The best thing about this tutorial is I've created it in such a way that at the end you should be able to go through the assets and go through the code and adjust things to your liking to really create a unique feel. Can't wait to see what you guys create. Let's get started. Okay, so let's get started. First of all, we're going to name our project, start a new project in Unity. Right now I'm using Unity 5.1 or 5.1.0 F3, so if you don't have the same one it might be different, but you should be able to follow along, and I'll always keep the comments in the video up to date. So I'll start a new Unity project, and we'll call it Infinite Runner 3 hours. So, and make sure it's clicked on 3D, and let's create our project. So for this, I'm just going to use primitives. We're not going to add any fancy artwork or anything like that. We're just going to make a simple base mechanics. This is more of a programming tutorial than anything else. But what's good about this is it'll serve as a template or a base plate for future games for yourself. So you might be able to add to this game and then actually chuck it on the App Store. You might be able to change the some of the physics or anything like that, and then chuck it straight on the Asset Store, the App Store. Sorry. Or the Galaxy or the Android store, and be ready to rock and or roll. So first things first, what we're going to do is we're going to create a 3D cube, and this for the most part is going to serve as our ground. So just name that ground. We're going to create another empty object. We're going to call that level. We're going to nest the ground in the level just to keep things organized. And we're going to create and with the ground, we're going to change the scale to 5,000 on the X, 1's fine on the Y, and let's say 100 on the Z. Now we're just going to leave that there for now. Now in the assets folder, we're going to create, in the assets area down here, under this folder, we're going to create some new folders. So the first folder we're going to create is scripts. Second folder we're going to create is, let's call it materials. Man, spelling is superb. The third one we're going to create is audio, and for now I think that will do us. So we're going to go into our materials first thing, and just because the white really frustrates me, and we're going to create a new material. So go right click here and go to create new material, and then we're going to call this grass. And because I said we're using primitives, we're not going to use anything but except primitives. So basically all I'm going to do is change the color of this. So let's just change it to a nice green. So all I did there is click on that icon there, and then come over here to change it to green. Let's get a nice, let's go for a nice like pastel green, I think is what we're going to do. So then we can go to ground, and we can actually we can go to materials here under the mesh renderer, and we can just drag on our grass texture, and then bang, we've got a ground. Now for those who, this tutorial is going to be a bit more fast paced, because we're going to try and get it done in the 3 hours like I said. So excuse me for going a little bit too fast at some stages, but that's just what we're gonna have to do to get this rolled. I kind of want this to be for people who just kind of want quick answers, so that's what we're gonna do here. I should make that a bit darker because I just don't like how light that is. And awesome, rock and roll. So we got the ground in here. It's got a collider on it, and we got the camera, which is facing there. Let's face. Okay. Next thing we're going to do is we're going to create a player. Now, like I said, this for the start it's just going to be a some primitives. So I'm going to create a let's create a sphere, and we'll call this sphere player. Because I've moved the camera around, it's changed the X, Y, and Z positioning. So make sure we go 0, 0, 0. Camera should be -10. Yeah, it needs to be lifted up a little bit. Well, there you go. There is our character so far. We can add a rigid body, and then if I just drag this up a little bit and we play the game, watch the magic, we've got physics. That is really awesome, people. So in a matter of a few minutes, we've got some physics, which is great. So to do that, just a bit because I just rushed ahead there, all I did is go add component and put on a rigid body, and that's how it goes. Okay, so we've got the player object now, and we're going to leave the player object white, I think, for this at this stage. And we are now going to create. Let's create our player move script. So right click, so open the scripts folder. Make sure to keep everything organized, otherwise you'll be pulling out your hair trying to figure out what's going on later on down the track in development. So we want to go to create, and we want to go create new C# script. I'm going to call this player underscore move. And if I just open that up, we'll just wait for it to open. I'm running on an old 2011 MacBook Pro at the moment, so it's seen better days. Okay, when you first open up any C# script, you'll see that you've got a few namespaces up here. So it's using Unity Engine and using systems.collections. They're just the most common namespaces that will be used. They'll appear as default. Then you got your class that opens up here, closes here. So anything inside here is within the player move class. And think of that as like almost like a giant function, a giant list of commands. And then we got two methods here, the start method and the update method. The start method runs once at the start of when the script is activated, so at the start of the game basically, this will run once, and update runs every single frame of the game. So for now, we're going to declare a public static int. Now, ints are whole numbers, and normally you wouldn't use the static keyword, but in this case we're going to do it. Just don't use static unless you kind of know what you're doing, unless you're following a tutorial like this. So what we're going to do is say public, which means that the variable is public, static, which means it can be accessed throughout the whole program, and what type of variable is it? Well, it's an integer, and then we're just going to call this player speed, and then we're going to equal that to 10. Press Command Save to save that, and then we are going to create. We're going to get rid of the start method because that's not needed, and we're going to actually change this update method, to a fixed update method. Now, fixed update runs every single physics frame, so it's just more reliable for what we're doing here. Tab in, and we're going to write game object dot transform dot translate vector 3 dot write, and then times player speed. I don't know why it's not coming up. Times time dot delta time. Oh, let's do fixed delta time. Okay, so that should work. And that is all we need to do for our script. Okay, so if we go back into Unity, it might throw an exception. Nope, it's not. I just don't know why it wasn't auto-completing there before. Okay, so then we're going to click on our player object, and we're going to go add component, and we can just type in player move and then click it on. But an easy way is to go into the scripts and click it, drag it over to the game object. So now we've got player move. Now if we press play, he should, in theory, move to the right. And it does, yay! But the problem is that the camera doesn't follow the character, which is the next problem. So just a quick point, whenever you're creating a game, you don't want to start off with, cool, amazing graphics or anything like that. You want to start off with the basic of the basic of the basic, and you want to go, okay, what do we want? Well, we want some physics. Okay, put them in. Okay, what do we want? We want that character to collide. Okay, we'll put that in, and we've done that. And now we've gone, okay, we want the character to move, and now we want the camera to follow him. And you just add to the game step by step by step. And because if you start off doing really amazing things, you might actually realize that they don't work. And you've just spent all this work putting it all in, and it doesn't actually feel good. So it's always good to prototype. Anyway, I digress. So let's create another script called camera underscore follow, and we'll open that script, and we are going to first declare a few variables. Private game object player. So instead of doing public, which is not always the desired access. You don't always want it to be accessible to everything throughout the program if it's public. So you can make it private, and then it can only be seen within this class and be used within this class, and can't be used within the inspector. So just because the way we're coding this, we're just going to make that private, and then we're going to say public float. Floats are like integers, except they're got decimal points in them, so that you can do like 1.22245 or whatever. You can have like a bigger numbers, and we're going to call this camera. Actually, it's always good to start with a small case letter at the start. Just good coding practice. Equals 5.0, and because it's a float, put an F. All right. On to the next thing. We are going to, in the start method, we're going to write player. Oh, I'll just change that back to small. Sorry. Player equals capital A and game object, capital GAM object dot find object with tag. Oops. Player. Okay. Next thing, we're going to change this to fixed as well, because we want it to be the same on the same scale as player move. And we are going to do a little comment here to make it easy for us to understand. You can just do // which means you can just comment things in, and we're just going to write X position follow. That's not needed, it's just something that will help us out. We're going to create a new variable called vector3 cam position, or campos, I'm going to call it, equals transform dot position. And then we're going to access campos variable. We're going to get the X in that variable, equal it to player dot transform dot position dot X minus 9.0 F. Finish. Then we're going to lerp our, so what this does is it creates a new variable, which is a vector3, then it accesses that variable on the X, and then it relates that to the player position, but then minus on the X plane -9. So that means that the player will be on the left hand side of the screen. Trust me, it'll all make sense in a second. Next line of code is we're going to get the camera to lerp to the actual position of the player. So transform dot position equals vector 3.lerp transform position cam position, and then I'll just do 3 times time dot fixed delta time. Okie dokie. And there, that should run pretty sweet. So what we're going to do is we're just going to go Command S to save that. We're going to go into Unity and we're going to grab the cam follow script and we're going to drag it on to the camera. Now when we press play, it doesn't follow. Oh, sorry, we need to go to player, we need to go to tag, give him the player tag. So I'm going to press play now. He's actually getting followed. So if you can see that, the camera is actually following the player and the players move along, but you can't see it here because there's nothing to compare it to. Okay. Next thing that we're going to do, which is actually really important, I should have done it before, is you go File, Save Scene As, and we're just going to call this Main. And just going to save it in the Assets folder, Save. And you'll notice down here, pop. So that's basically, a scene is basically like a level. So yeah, that's where it is there. And then we want to save our project as well. Alright, we're not going to lose anything, everything is good, everything is A-OK, sweet, let's move on. Okay, now here comes the fun part. Everybody ready? We're going to do the player controls. Yep, that's what we're doing. Alright, so what we're going to do is create a new C# script and write player _ controls. Open that bad boy. And then we are going to do a couple of things first. First, we are going to create a public static float. I'm going to call it jetpack fuel equals 1.5f finish. Next, we're going to create a public float jetpack force equal up to 10.0f and close. Then in the update method, now it's important, let's get rid of the start. It's important to, in update, this time we don't change it to fixed update. I had a problem with a game once in which I had the controls in fixed update, and because I don't get called every frame, sometimes you press the button and it would miss it, and then you wouldn't actually get, it wouldn't actually work very well, and that was very frustrating. So first thing is, first we are going to write an if statement. So if tab in. If input dot get button, and then we're just gonna write jump. So you can edit that in input settings. If you go edit, I think, and input settings, you'll be able to edit that. Oh, let me just, I think it's, yeah, let me just zoom in for you. That's a bit better. Okay. So if you press the, if you press the jump button, I'm going to do and jetpack fuel, I don't know why it's not popping up again, is greater or equal to 0.001, let's say, F, open curly bracket, close curly bracket, press back, press space, ready rock and roll. So you just want that, sorry, that's just how I do it. And then we're going to make we're going to tab in boost up. So what happens is if you press the jump button and you've actually got some jetpack fuel, just make sure it's spelled the same. Yep, you've got some jetpack fuel. Then it's going to run the method boost up. Now we haven't got a boost up method yet, but that's okay. We'll build that in a sec. And then we want to go else. Same thing. Actually, we don't need an else yet. Let's just leave else out yet. So it just runs the boost up. Alright. Alright, so now we can create the method void. Void basically means nothing. A lot of people who come from JavaScript are like, what does void mean? It means nothing, basically. Oh, sorry, yeah, void is basically just like it's saying nothing, but in C# you can have things like enumerators and things like that that are a bit more complex, but just for now, don't worry about the word void. It just basically means nothing, but you have to put it at the start of methods. That's why void update has got a void start. And anyway, we're going to create our own method here, void boost up. And just a bit of formatting here. Sometimes I'm pedantic, sometimes I'm not. Anyway, jetpack fuel equals mathf.lerp. Oh, actually, let's do mathf.move towards. It'd be better for what we're doing. And then we want to move towards. We want the current float, which is jetpack fuel, to move towards 0 at time.fixed delta time. Alright, here. Then we want to get component. So what this is going to do is going to find a component on the game object that this script is attached to. And as we added the rigid body at the start, it should have one. So rigid body. And then the old spaceroonie dot add force. Where do we want to add force? We want it to be a new vector 3, and we want it to be 0 jetpack force. And make sure your spelling is correct, otherwise you'll be tearing out your hair. Alrighty, and that should work. Let's just give that a test. So if you, oh, sorry, got to go to the player and add the player control script. Bang, it's on there. You can see your public variable there, jetpack force. Oh, so press play. You can see he's got a little bit of jetpack force, but it does not work. Let's chuck another, put it on 100. Let's see what happens now. It's probably going to shoot. Yep, he shoots right up. You can see him over here just shooting way too high. Which brings us to our next problem. We've got to get the camera to follow him on the y-axis as well. But just for now, that's fine. It works. We'll just add the next little part to this. Go back to the script, and we want to do void on collision enter. I want it to be a variable called collision, and we're going to call the variable col, and then we're going to say if col dot game object dot tag equal to ground, then what we're going to do, just something very simple, make the game fun, jetpack fuel equals 1.5f, which is the original jetpack fuel. So every time you touch the ground, the jetpack fuel is going to go right back to the top again. Now we could put a lerp or something in there to make it like slowly gain over, but I think it's just fun to have it completely unrealistic and just have it completely recharged straight away. I think that actually works pretty well. But feel free to change that to a lerp or something like that in the future. Alright, save that and let's go back to the game. And so, oh, got an exception. What have we got here? Oh, sorry, didn't finish it with a semicolon. So you should be able to shoot up, and you continually shoot up. Character is still falling down. Oh, he's come over the arc now. It's falling down. You can't actually move him up anymore. Oh man, it's a big jump. And he's fallen through the floor. Damn it. Alright, so first, because he just fell through the floor there, we want to go over to player and we want to make the rigid body, see this collision detection, we want to make it continuous. So he doesn't fall through the floor accidentally. It's heavier on the CPU, but it's going to be fine. So if I can keep pressing the spacebar until basically, I'm just hovering along here, until basically it runs out. The jetpack fuel runs out. And I can't do it, but now he's on the ground, and when he hits the ground, he should recharge. So if we go to ground here, we can go to inside level, nested object called ground, go inside that, go to the tags. I'm going to add a tag, and it'll come up with a list here. The list is empty at the moment. Click the button to make a new tag, call it ground, click out of it again, click on the ground, and then assign that new tag ground to the ground object. So I might just for niceness sake, I might just change it to 50. We're just debugging now, people, so it's not that important. So he can continue to fly. I'm pressing the space bar. Eventually he'll run out of fuel. And I can't do it anymore, but as soon as I touch the ground, I've got fuel again. Woo! We're on our way, people. We are on our way. Alright. Okay, that seems pretty good. It seems like we've got it all down pat for that side of things. Alright, now to move on to the updating the camera so it follows us on the y-axis as well. Alright, let's do that. Go back into the camera follow script, and we want to space. Okay. Then we want to go / y position follow cam post.y. So this is the same variable we used up here, we declared up here. Now we're just accessing the y axis of this vector3 variable. And we're going to equal that to player dot transform dot position dot y plus 2. I think that should suffice. Then we want to go transform dot position equals vector3 dot lerp, and then we're going to go transform dot position. We want to go to cam position 7.0f times time dot fixed delta time. Sweet as, and that should work. We should be able to rock and roll with that. So let's give it a go. Back to Unity. Press play. Okay, so now you can see that we are moving along. It follows up and down, and you can notice the horizon, which looks absolutely horrible at this stage, but that's okay. We're going to fix that right now.